Alright, good day everyone. Welcome to today's class. If you can hear me and you can see me, let me know. If you can hear me and you can see me, let me know. We're about to kick off. We are about to start. If you can hear me and you can see me, please let me know, let me know, let me know. Alright, we are about to start today's class. Please, you can hear me very well. Please let me know so we can kick off. Today is going to be an exciting class. I'll show you're going to learn new things. So this is what we have as our outline on the board. You can take it down, take note of that, what we're going to be learning today. That is the outline on the board. That's the outline on the board. So the first thing we'll be looking at today under geometry is the what? Basic angle and the properties. That's the first thing we'll be looking at. So make sure you can hear me properly and you can see me. Let me know if you can hear me properly and you can see me, so we can proceed. Alright, good evening Duru Big Polo. Good evening Chisom Divine. Good evening to you all. Good evening. Okay, let's wait for others to join. Alright, while we are waiting for others to join us, okay. Is this better? Is the flash too much? Or should I turn it off? Let me know in the comment section if you like it with the flash or without the flash. Which one do you prefer? You can hear me, you can see me, let me know. Good evening, Veronica. Good evening, Veronica. All right. So we can start, right? We can start. Good evening to everyone. Welcome to today's class. Good evening, everyone. So please, let's give those that are not online 1 more minute before we kick off. One more minute and we are going to kick off. One more minute and we are going to kick off. Okay, so good day everyone. My name is Kalabo Beki Divine and I'm going to be your instructor for today. So today we'll be looking at basic angle and the properties. we'll be looking at triangles, and similarities, we'll be looking at the polygons, sum of angles, we'll look at circle theorems, angles in a circle, we'll look at circle theorems, tangents, we'll look at coordinates, geometry, distance, midpoint, we'll look at gradient and equation of a line, we'll look at loci, we'll look at the plural of locus, and we'll look at bearings. In case I'm too fast, there's a feature on YouTube where you can reduce the speed by 0.5 so that you follow up, so you catch up, because we'll be covering a lot today. So let's go. Let us go. So basic angle and properties. Basic angle and properties. That's the first thing we'll be looking at. Basic angle and properties. Alright, basic angle and properties. So I think I'll turn off this flash. It's too bright. I'll turn it off. This will be better. Good day, Joshua, Ojigwe, good day, Divine, good day, Veronica, and good day to everybody online. Alright. So we started. We have started. Alright. So for basic angles, before we look at an angle, let's look at this. Let's say we have two lines. Now, for these two lines, let's say this line is line A, and this is line B, and this is line C, and this is line D. As long as these two lines are not intersecting each other or meeting each other at any point, even though they continue either to the right or to the left, they are called what? Parallel lines. They are called what? Parallel lines. So now let's convert these parallel lines now. Let's say we have another line again here, and we have another line here. These are also two straight lines, right? Two straight lines here. Let me draw it very well. You have a line here, and you have another line here. So this point, when they meet, is called an intersect. And what? Intercept. And this intercept forms what we call angles. They form what we call angles. So we can call this A, we can call this B, we can call this C, we can call this D. They form angles. These intercepts, they form what? Different angles. Now, if we call this, let's put here, this is a point P. Now, another way you can write angle, you can write it as angle DPB. You can write it as angle DPB. You can also write it as what? Angle APC. Another way you can write this angle is using the symbol. So this symbol now will represent this angle. So it should now be this angle what? DP what? B, or angle what? APC. So that's another way we write angle, using this symbol. Then if we take this angle out, This will be called an arc. This will be called an what? Arc. So moving on, if we have two lines, let's say we have two lines and they intersect, forming an angle. Forming an angle. This point where they intersect, forming this shape, this square shape, this is called what? A perpendicular. And a perpendicular forms what we call a right what? Angle. It forms what? Right angles. Now this is what? A perpendicular. This is a perpendicular. They meet at 90 degrees and they form right angle. Now let me keep going. Since we have these as what? Perpendiculars, right? Forming what? Right angles. So if we have an angle smaller than this right angle, let's say we have an angle smaller than the right angle, this angle will be called what? An acute angle. Then if we also have an angle bigger than the 90 degree, that's the perpendicular angle. So let's say we have an angle bigger. We'll call this angle what? An obtuse angle. So we have a right angle, we have an obtuse angle, and we have an acute what? Angle. So we have another type of angle. Let's say this is a straight line and we have an angle. So this is called a what? Straight line angle. A straight line angle. A straight line angle. So from this direction to this direction, this is a what? Straight line angle. So now this perpendicular angle or right angle, if it's divided into two and you have two angles, and we say this angle is angle A and this is angle B, so these two angles are called what? Complementary angles. So the two of them will form what? This right angle or perpendicular angle. Then if we have another one, let's say this is the center point, and we have two angles. Let's say this is angle A and this is angle B. Now these two angles will form a straight line angle, which is these two angles, the addition of these two angles is called what? A supplementary angle. So observe, complementary angle, both of them are equal. While for this supplementary angle, they are not what? Equal. Alright, so this is all we have for basic angles and their what? Properties. So next up, we look at something else. We look at triangles. We look at what? Triangles. So let me clean the board. Please hope you're taking notes. Hope you are taking notes. So next up, we're looking at what? Triangles. Triangles. Alright. So first of all, we'll talk about the 4 types of triangles. The what? 4 types of triangles. And I'll tell you about each of them. We'll start with the first one. Now, a triangle is made up of 3 different sides, and this is also called a polygon, which is a 3-sided polygon, because it's a plane figure, a flat figure, is made up of straight lines, and it is closed. It has a closed boundary. That's what makes it a polygon. But now we're talking about types of triangle. This first type of triangle has 3 equal sides. 3 equal sides. 3 equal sides. You can also represent it with this dash. And for a triangle with 3 equal sides, it also has 3 equal angles. 3 what? Equal angles. So we'll write that what? 1. All what? Sides are exactly the same. And if you say all sides of this triangle are exactly the same, it is called what? An equilateral triangle. It is called an equilateral triangle, which has all sides the same. 2. It has what? All 3 angles. 1, 2, 3. All what? 3 angles are what? 60 degrees. They are the same, because we know that the sum of the internal angles of a triangle is equals to 180. So if we do 180 over 3, we will get what? 60, because all 3 sides are the same. Also, the third point is that it has 3 lines of symmetry. 3 lines of symmetry. 1, 2, 3. It has 3 lines of what? Symmetry. And it is what? Rotational symmetry of order what? 3. if you rotate it to this other side, to see the same thing. If you rotate it to this other side, it's the same thing. Rotate it to this other side, the same thing. Rotate it to this other side, it's the same thing. So it has the rotational symmetry of order 3. That's the fourth point for the equilateral triangle. Rotational symmetry of order what? 3. So this is just one type of what? A triangle called an equilateral triangle. So next up, we'll look at another type of what? Triangle. Please take note of this. Let's look at another type of triangle. So I'll draw the shape. Now, for this triangle, we have two sides that are what? Equal. That's why we have this dash. Two sides are equal. And we also have two angles that are what? Equal. Therefore, this triangle is known as what? Isosceles triangle. Isosceles triangle. Please take note of these properties of the isosceles triangle. Two sides that are the same in what? Length. 1. 2 what? Sides that are the same in length. We have two angles that are the same, which is this angle and this angle. Then we have what? One line of symmetry which is passing through here. We have what? One line of what? Symmetry. Now we have no rotational what? Symmetry. No what? Rotational symmetry. Please, if you have any question, please let me know in the comment section. Ask me any question you have in the comment section. Please make sure you are seeing the board properly too. I don't know where I should turn on the flashlight. They should bring the lights, everyone will be bright. Alright, so let's proceed to the third type of triangle. The third type of triangle we have is called what? Let me draw it first. The third type of triangle, let's draw that very fast. So we have something like this. Alright, so this is called a what? Right angle triangle. A what? Right angle triangle. This is the right angle. This is the what? Right angled triangle. And for this right angle triangle, we don't have any line of symmetry. So we write no line of symmetry. And no rotational symmetry. Now, for this, we also have another type of right angle triangle. Let me draw it here. Now, notice the difference. This type of right angle triangle has two parts that has equal lengths. This triangle has what? Two parts or two lines with what? Equal length. And since there are two with equal length, it's also called what? An isosceles. An isosceles what? Right angled triangle. An isosceles right angle what? Triangle. It also has what? If you divide it here, it has one line of symmetry. One line of symmetry. It has one line of what? Symmetry. Finally, let's look at the last type of triangle. The last type of triangle. Now, this triangle has a very complex shape. It has a complex shape. This triangle has a what? Complex shape. When I mean complex shape, I mean the three sides are not equal. The three sides are not what? Equal. All sides are different lengths. So the first thing is that all sides are different lengths. So take note of that. And since all sides are different lengths, it is called a what? Scaling triangle. A scaling triangle. And since they are different lengths, they are also what? Three different angles. Three what? Different sizes of angles. They have also no line of symmetry. So I can indicate it like this. Three different sizes. They have what? No line of symmetry. Are you taking note of all these points? And they have no rotational symmetry. So this is the fourth type of what? Triangle. Next up, let's look at what we call polygons. We'll look at what we call what? Polygons. So we'll look at what we call polygons. So what do we understand by polygon? It's a very simple English. A polygon, take note, a polygon has a plane closed figure made of line segments. You can say a polygon is a what? Plane closed figure. Let's say we have this, we have this, we have this, so it's a plane closed figure made up of line segments. So let's underline a plane 1, let's underline closed figure 2, and let's underline line segment. So I'll be explaining why I say that. So now let's draw this. You know how we normally draw a cube? We draw 2 boxes. We'll now do like this, do like this, do like this, and do like this. Do you remember this format? Yeah, orthographic projection. Then now let's say we have another shape like this. Let's say we have a shape like this. We have a shape like this. Then we have one shape that looks like this. As a special shape. Now we'll confirm these shapes. We'll know which of them is a polygon and which of them is not a polygon. Now I said first of all, a polygon is a plane. That means the shape must be in 2 dimensions, flat. As 2D, must be in 2D, 2 dimensions. Secondly, it must be closed and not open. And thirdly, it must be made of what? Line segments. So now let's confirm this one. This is called a triangle, a 3-sided polygon. Note, it is flat, is of 2D shape, that's 2 dimensions. It is closed and is made up of 3 line segments, 1, 2, and 3. So this is a polygon. Let's look at this rectangle or square. Okay, it's a rectangle since the sides are not the same. So a rectangle is a what? 4-sided what? Polygon. And it's also closed and made up of line segments. So this is a what? Polygon. Now let's look at this shape, a 5-sided polygon called a pentagon. This is a what? Rectangle. This is a triangle. This is a pentagon. This is a cube. This is a star, a circle, an oval shape, and a not closed line segment. So for the pentagon, since it's 5-sided, it's flat, is closed, and is made up of line segment, is a polygon. Now take note of this. This is different. This is what? 3-dimensional. You can look at it from here, you can look at it from here, and you can look at it from this point too. So this does not qualify as a what? Flat shape. So this is not a polygon. Now this one, they said, is a not closed line segment, and since it's not closed, it has disqualified itself from being a what? Polygon. So this is not part of a polygon. And over though it is closed, but it's not made up of line segments, and it is a flat shape, but it's not made up of line segments. It is closed and it is flat, but it's not made up of line segments, so this is wrong. Similarly with the circle, this is wrong. Now take note of this. This is closed. This is a flat shape in 2 dimensions, and it's made up of line segments. So this is a what? Polygon. So now I'll show you the difference between what? A polygon and a non-polygon. Please hope you're taking note of these important points. Next up, we'll look at what? Another subtopic called what? Cycle theorem. After we look at cycle theorem, then we'll do calculations on different polygons, triangle, square, rhombus, parallelogram, and the rest. So let's go. Hope you're set for today's class. It's going to be an exciting class. Please take down, write what is on the board, write. Because this next session will be very interesting. It will be very, very interesting. Alright, I believe you're done writing, so let's proceed. So for this cycle theorem, we're looking at various parts of the cycle. So now this is a cycle, and this external boundary of the cycle is called what? The circumference. And from the center of the circle, this is the center of the circle, from the center of the circle to the circumference is called a radius. While from one point of the circle passing through the center to another point of the circle is called a diameter. Please, are you taking note of these things I'm saying? Now, if we have a circle here, and this part is cut, and we have a small portion here. This small portion here is called a chord. And now a circle can be divided into 4 parts. This part now, let's bring it out. This part joining these two, this curved part joining these 2 lines is called an arc. It's called what? An arc. And for us to have an arc, this part now, they are called segments. These are called segments. We have 4 different segments of the circle. Segments. So now, take note, if we have a circle and we have 2 points, from this point we have a point touching here, and this point we have a point touching here. We now have another point again from here, touching here, and from here, this same point touching here. We will say that these 2 angles are what? Equal. We will say that those 2 angles are what? Equal. Example, if they are what? 45 degrees. Also, if we have a circle, and this circle we have something like this, and we have this angle here as what? 55. So this interior angle here will be twice the size of this angle. So 55 times 2 will be what? 100 and what? 10. Please take note of these important points I'm making. Now, let's say we have a man standing here and we have a tree here. So if this man is looking at this tree at this angle, let's say 22 degree, that is what we call a what? Subtended angle. A subtended angle. Please take note of that. It's called a what? Subtended angle. Now, this point let's say we cut it from here. This is called a what? Sector. And if we have a circle again, and we have a line touching, a straight line touching the what? Circle, or passing on the circumference of the circle, it is called a what? Tangent. It is called a what? Tangent. So this is what we have for what? Circle theory. Next up, let's do some calculation. A little bit of what? Calculation. Let's do a little bit of what? Calculation. Or should I explain loci first? Then we'll go to gradient. If we explain loci, we'll go to gradient and equation of a line. We'll go to bearings. Then we'll solve one or two questions. Okay, let's go. Let me explain a loci at once. Since I'm talking about circles, let's just jump some topics and go straight to loci. Then we'll come back to those other topics we jumped. Is that okay? Alright. Let's go to loci. Now, what do you understand by the word loci? Loci. Loci is the word plural, while locus is called what? Singular. And loci is a set of points, or let's say locus, in bracket, loci is a set of what? Points. I know the place is getting darker. Please, can you see the board? That satisfies a condition. So loci is a set of points that satisfies that what? Satisfying a condition. So loci is a set of points that satisfy a what? Condition. Now we have a point here. We have 2 points here. We have a straight line here, and we have 2 lines here. Now we are going to find the loci of. We're going to find the loci from a point. We're also going to find the loci from 2 points. We'll now find the loci from a straight line, which is this. finally for this, we'll find loci from two lines. Alright. Should I turn on my torch? Please let me know if I should turn on my torch in the comment section. If the place is too dark, let me know so I can turn on my torch. Can you see the board clearly? Let me know in the comment section. Let me know in the comment section if I should turn on my torch. Or if the board is clear, still let me know so I can proceed. Alright. Let me see. Is anybody saying anything in the comments? Okay, she said yes, sir. So like this, is it better? Is this better? Turn on the torch. So check if it's better now. I have turned on my torch. Check if it's better. So we can continue. Let me know in the comment section. It's better. Alright, so this is better. So let's continue from where we stopped. So now, for us to get the loci from a point, we simply, let's say, they say we should find the loci from this point at 5 centimeter. So measure now this 5 centimeter out. So this is 5 centimeter, right? The radius is 5 centimeter. So the loci is simply telling us from this point 5 centimeter away from this point. So that is how we find our loci for a point. So the loci will be here, will be here, will be here. 5 cm away from this what? Center what? Point. Now, if we have loci from 2 points, and they say we should find the loci from like 4 cm, and we have 2 points here now. If we measure 4 cm here, I'll measure 4 cm here, and let's say maybe the 4 cm, they stop here, 4 cm here, 4 cm here. So where they intercept, or where they meet to form a perpendicular, that is what we call the loci from what? 2 points. Now, for the loci from a straight line, let's say we find the loci from a straight line of what, like 2 cm. So first of all, we'll take 2 cm out of this point. Now let's say from here to here is 2 cm. So every point away from the line should be 2 cm. Every point away from the line should be what? 2 cm. Both up and what? Down. Now for this part, so the same thing. 2 cm, 2 cm, 2 cm, 2 cm. So our loci will be something like this. So that's the loci from a straight line. And finally, they say we should find the loci from 2 lines. And they say this locus point should be equidistant from the point. Let's say it should be equidistant. That means they should have equal distance. So for it to be equidistant, you simply what? Put your compass here, you bisect here. You put your compass here, you bisect here, and you join it from the center. So that will be our what? Loci for the point that satisfies the condition. Now the loci So now we are done with loci. Let's move on to something else. Let's move on to how to find let's look at how to find the equation of a line when given a gradient passing through what? 2 points. So let's look for how to find the equation of a line. Equation of a what? Line. Now, to do that, so this topic will be what? Gradient and equation of a line. Gradient and equation of a line. So if you have a question, find we say we should find the equation of a line with gradient. Find the equation of a line with gradient. Let's say our gradient should be, let's use 5, passing through the point which point should we use? Let's say passing through the points 2 and 8. Let's say passing through the point 2 and 8. Alright, so what will our solution look like? To find the gradient, or let's to find the equation of a line. Now, first of all, gradient is also known as the word slope. And the equation of a straight line is simply what? Y is equals to what? Mx plus what? C. And y is our slope. YC is our intercept. And we have 2 points where we are passing through, x, which is this, and we have y, which is what? This. So they're giving us our gradient as 5, they're giving us x and y, and they say we should find the what? Equation of a line. We don't know what C is, right? So the first step is to what? Find C. So if we want to find C, we will simply what? Substitute in the value we have been given. So we will now have that y is equals to m is 5, is equals to 5x plus c. Now we know that x is equals to 2 and y is equals to what? 8. So we simply will substitute. And if we substitute, we will have that 8 is equals to what? 5 times x, which is 2, plus c. 5 times x is 10. So we have 8 is equals to what? 10 plus what? C. Now, Or let's make this y value bigger. Let's make it bigger. Let's need something like 12. So here will be what? 12. Let's change this to what? 12. Let's change this to 12. So now, if we change it to 12, all the values for y will change to 12, right? So then, so we take 10 to this side, we now have what? C is equals to what? 12 minus 10. We took 10 to this side, so 10 will become negative. So it will now be 12 minus 10 is equals to what? C. And we have that C is equals to what? 2. Therefore, since we have gotten C as equals to 2, we can write our equation of a line to be what? Y is equals to what? M, which is 5. 5x plus, we have our C as 2. So this is going to be our equation of what? The line. Very, very simple. Very, very what? Simple. Now, let's solve one question on bearing. Then we will now solve many questions on areas of different polygons. Let's solve one question on bearing. Then we will now solve on area of different polygons. So now, bearing so we should find the bearing of, this is an example, find the bearing of A. Now let's draw what they say we should find. We have this, and this is not. This is not. We have an angle from here to here. We also have an angle from here to here. So this is not. This is what? Not. And they say we should find the bearing. Let's call this A, let's call this B, and let's call this C. So we have the first one, B from A, and they say we should find the second one, which is find A from C. Now to do that, we're giving this angle as what? 72 degrees, and we're giving this angle as 227 degrees. No, not 227, 228 degrees. And we are giving, okay, so we are giving these two angles, and they say we should find the bearing from B from A, that's B from A, and what? A from C. So now the first thing we do, B from A, that means you're starting from A, and if you're starting for the bearing, you're starting from the north, right? So from A, from the north, we are going towards B. So this is the line leading to B. So B from A. We are heading towards B, right? So we are finding this angle. This angle is unknown. Now, we know that these angles are what? Equal angles. As complementary angles are what? Equal angles. So now if we have 228 here, and we know that angle on a straight line is what? 180. And this is a straight line, right? So here, from here to here is 180. So what is from here to this point? It will be simply what? 228 minus 180. So if we do 228 minus 180, we'll have our answer to be 48 degrees. So if here is what? 48 degrees, this side should be what? 180 degrees. So since now this shape is coming out, where we have this angle, so here too will be equal. Since this shape now, if we flip it like this, to be like this. So if here is 48 degrees, here should be what? 48 degrees. Therefore, we have gotten from B from A as what? 48 degrees. Next up, they say we should find A from C. Now this is C, right? And we start from the north. From C towards A will give us this angle. And we know that the internal angles of a triangle is equals to 180. That means this angle plus an angle which is unknown here is equals to what? 180. So 180 is equals to what? 72 plus what? 48 plus what? Our unknown. Let's take our unknown as x. So 72 plus 48 will give us what? 72 plus 48 will give us 120. So it should be 120 plus what? X is equals to what? 180. So if we take 120 to this other side, we have that x is equals to what? 180 minus what? 120, which is equals to 60 degrees. So we have this angle as what? 60 degrees. Now, since we've gotten this angle at 60 degrees, we know that the total angle around a point is 360. So if we want to complete this point, it's 360. So the angle from here to here will be what? 360 minus what? 60 degrees, which will give us what? 300 degrees. So we now have that the angle of A from C, that is from here to this other part, will be what? 300 degrees. So our answer will be what? 300 what? Degree. Are you seeing it? Very simple, right? For bearing. Please look at it very well. Very, very what? Simple. So after that, let's start solving questions now on different types of polygons. Look at the square. We'll find the area of different types of polygons. Look at the square and the rest. So let's go. Still under geometry. Still under what? Geometry. So this is the last thing we look at today before we call it a day. This is the last thing we look at for today before we call it a day. So stay with me. So now, let's look at the first shape. The first shape like anytime I want to call it a day, this period, our marker will start behaving anyhow. So let's look at the first shape. This is a rectangle, and we say this rectangle, this shape is what? 6, and this is 4. Now, not just 6 meters and 4 meters. So the area of a what? Rectangle will be equals to what? Length, which is 6, times what? Width, which will give us what? 6 times 4, and will give us what? 24 meter square. Now moving on, let's look at a triangle. If you have a triangle and we say the height of this triangle now is equals to 3, and we say the breadth of this triangle is equals to what? 4. We know that the area of a triangle is going to be what? Half breadth times height, which is equals to what? 1/2 times 4 times 3. 2 here will enter 1, 2 here will enter together 2. So we left with 2 times 3, which is equals to what? 6. Please take note of all this I'm saying. Now let's look at another shape. Let's look at another shape. Let's say we have this shape. Let's look at this shape. We have this shape, right? Alright. Can you see the shape very well? This is the shape we have. And in this shape, we have this part from here to here to be 5 meters. We have this other part to be what? 6 meters. And we have this angle, and we have the height to be what? 9 meters. So if we have it like this, to get the what? Breadth, we'll simply add 5 plus 6, which gives us what? 11 meters. So having 11 meters, we'll now have our breadth as what? 11 meters, and our height as what? 9 meters. Now from our formula, we know that area of a triangle is equals to what? Half breadth times what? Height. So we now have that area is equals to we know that area is equal to what? 1/2 times what? 11 times 9, which gives us 1/2 times 11 times 9 is what? 99. So 1/2, which is 0.5 times 99, is simply what? 99/2, which will give us 40 what? 49.5. 49.5 meter square. 49.5 what? Meter square. 49.5 what? Meter square. Now next up, let's look at something else. Let's say we have an equilateral triangle. And for the equilateral triangle, we have all sides to be what? 10 meters, 10 meters, and 10 meters. Now for an equilateral triangle, we know that the area is simply what? The square root of 3/4 times the length of the side. Now, the length of any side, let's just call it L. So the length of any side raised to power what? 2. So we now have that what? L, since L is equal to 10, we will now have our solution to be like square root of 3/4, square root of 3/4 times what? L, which is what? 10 square. L square, 10 square. We now have what? Square root of what? 3/4 times 100. So if we cancel 4 here, we have 1. If we cancel 4 here, we have 25. So our new area will be what? 25√3. 25 what? √3. √3. Alright, so let's look at another shape. For this other shape, let's say we have an equilateral, like a square, where all the sides are equal, and we say the square is what? The length and the breadth of the square is 9. So our area will simply be what? Equals to what? L square, and we know that L is equals to 9, so our area will be what? 9 square, which is equals to what? 81. Now, let's look at another shape. Okay, you can draw the shape at this other side. So now we have a circle, and they say we should find the what? Area of the circle, and we're given the diameter. The diameter is from the center point, from the circumference of the circle, a line passing through the center point to the other side. It's called the diameter. And we say that our diameter D is equals to what? 10 meter. So now we know that area for the triangle A is equals to pi r square, and we know that the radius is equals to diameter over 2, which is what? 10/2, which is equals to 5. So area will be what? Pi r is 5 squared. So it's now the area equals to what? 25 pi. Please take note of this. Take note of what? This. Now let's look at another shape. If we're given let's say a portion of a circle, and this portion is what? 60 degree. Now, because we're giving this portion at 60 degree and we're giving our radius r as what? 10, And they say we should find the portion, the area of this portion. Now remember, the total angle of a circle is what? 360 degree. So now to get this portion, and we know that the area of a circle is what? Pi r squared. So to get this portion, we'll take the fraction of this 360 as just the 60%. So we'll now have that our area will be what? 60 over 360 times what? Pi r squared. Which now give us 60 here, will give us 1, 60 here, will give us 6. So it's now the 1 over 6 pi r is what? 10. 10 what? Squared. Times what? 10 squared, which will give us what? 100 what? Pi over what? 6. 10 raised to the power 2 is 10 times 10, which is 100. 100 times pi times 1 is what? 100 pi over 6. 2 can enter here to get what? 3. 2 can enter here to get what? 50. So we now have what? 50 pi over what? 3 as our what? Area. So now let's look at another shape. Let's look at another shape. Okay, let's say if we're given this shape, we're given this shape which is called a semicircle, and we're given a radius r, and our radius is like, we're given a radius of r equals to 5, r equals to 5, and they say we should find the area of this semicircle. Normally we know that area of a triangle of a circle is pi r squared. So to find a semicircle which is half of a circle, we simply do our new area will be what? A equals to what? 1 over 2 times pi r squared. And we know that r is 5, so it's now be A is equals to 1 over 2 pi 5 squared. 5 squared is 25, so area will be 1 over 2 pi what? 25. So 25 times pi times 1 will now be what? 25 pi over what? 2. Please take note of all these areas in this geometry. Please take note of all of them. Take note of all of them. They are very important. Very, very what? Important. Now let's look at another shape. Another shape. Let's look at another shape. Let's say we're given this shape, and we're asked to find the area. We're asked to find the words area. Please, if you can see the board and you can hear me, let me know in the comment section before we proceed. Let me know. Can you see me? Please let me know in the comment section if you can see the board very well. Let me know. This is a parallelogram, and we are asked to find the area of a parallelogram. Can you see the board? Can you hear my voice? To find the parallelogram area, the formula is simply what? B times H. where h, let's say our h now was giving us 10, and our b, that's the breadth, was giving us 5. So the area will be simply what? 5 times 10, which is what? 50 meters square. That is for a what? Parallelogram. Now, let's say we're given the same parallelogram, but this time they did not give us our height. This time they did not give us our what? Height. And they now broke this parallelogram down like this. So this part is a triangle, and they said here is 5, here is 9, here from here to here is 3, from here to here is what? 6. So now we are not giving the height is unknown. We are only giving the hypotenuse of this triangle as 5 and the base of this triangle as 3. So now we'll bring out this triangle, this right hand triangle, 5 and 3, and use this Pythagoras rule. Oh, finally they brought the lights, thank God. And use the Pythagoras rule. So now let's say this is h, right? Now we'll now use what? A square plus what? B square is equals to what? C square. And this part now, let's say this is B, this is A, so we'll now have 3 square plus what? B square is unknown, so it will be B square. C square is the hypotenuse side, 5 square. So we'll now have what? 3 square will be what? 9 plus B square equals to 5 square will be what? 25. So we'll now have what? You carry 9 to the other side, now be B square is equals to 25 minus 9, which is B square equals to what? 16. You take the square root of both sides. This square root cancel the square. If you take the square root here, b will be equals to what? 4. So we are putting b as what? 4. And now we're putting our what? Height as what? 4. So now we know that for a parallelogram, it is simply what? Area equals to breadth times height. And we have our breadth as 9 and our height as 4. So it will be what? 9 times 4, which is equals to what? 36 meters square. All these are in meter. All of them are meters. So it will be 36 what? Meter what? Square. Please take note of this. Now let's take one more example. Let's take one more example. Now we are doing this trapezoid. And they give us this as 10 and this other length as what? 20. And the height now is what? The height is what? 8, all in meters. And they say we should find the what? Area. So now the area will simply be what? 1/2, which is half. You add this first one, which is the length 1, or we call it breadth 1, plus b2, which is this one, times the h, which is this, to find the area. So we now have what? 1/2 into b1 is 10 plus b2, which is 20, times 8, which is h. So 10 plus 20 will be what? 30. 2 here will be 1, 2 here will be 4. So we now have 10 plus 20 is what? 30 times what? 8 times 4. Sorry, since we have divided. So it now gives us what? 120 meter square. So this is how you find the area of the what? Trapezoid. The previous one we did was the parallelogram. So are you seeing it? Now let's take our final example before we call it a day. the final example before we call it a day. Still on this trapezoid, but this time they did not give us our height. They did not give us our height. And this trapezoid now we have this is broken down like this, and they give us this hypotenuse as what, 10. They give us here as 12. They give us here as 24. So they say we should find the area. This is also 10, but they don't give us this side. They give us the total length from here to here as what, 24, from here to here as 12. I know these are right angle triangles, and this is a trapezoid. So the first thing is to what? Since here is 24, that means from here to here we what, 12. That's from here to here, 12. And 12 minus 24 is what? 12. 24 minus 12 is equal to 12. If divided by 2, we'll be left with what, 6. So from here to here will be 6. From here to here will be what, 6. So now we have our hypotenuse as 10 and our adjacent as what, 6. So we need to find this height so we can calculate what, area. So if we bring out this right angle triangle, we will now have what, here to be 10, here to be 6. If we use a squared, that's the Pythagoras rule, plus b squared is equal to c squared, where this is a, this is b, so this is what, c, this is a, and this is b. So if we substitute, we have our a as what, 6 squared plus b squared, which is unknown, is equal to c, which is 10 squared. So it will now be 36 plus b squared equals to what, 100. So now we now carry 36 to the other side. We now have b squared is equal to 100 minus 36, which is equal to what, 64. So b squared, we take the square root of both sides. This square root to cancel this square. We take square root of 64. We'll be left with b is equal to what, 8. So we are getting our height from here to here as what, 8. So now the first length or breadth 1, that's this one, plus b2, that's this one, times what, h, that's the height. So we now have what, area is equal to 1 over 2 into b1, which is 12, plus b2, which is 24, times what, 8. 1 will cancel, 2 will cancel here to get 1, 2 cancel here to get 4. So we have a is equal to what, 12 plus 24, that's 36. 36, 12 here plus 24, right? That's 36. 36 times 4. So area will be equal to what? 36 times 4. Now, 36 times 4 is very simple. We'll do 30 times 4, which is what? 120. We'll do 6 times 4. 6 times 4 is what? 24. We'll add the 2 again. 120 plus 24 will give us what? 144. So 36 times 4 is what? 144. So this is our new area. So we've come to the end of today's class. Hope you enjoyed today's class. If you did, please make sure you refer this class to your friend. Make sure you like and drop a comment section. Drop a comment in the comment section. If you have questions too, you can also ask me. Ask me either in the comments or you ask me on our WhatsApp group. Thank you for staying to the end of today's class, and we'll see you same time tomorrow by 8 o'clock, same time, same location. Thank you and see you in the next class. I remain myself, Divine. Thank you for watching and thank you for staying in the end. Please don't forget to subscribe if you're new to this channel. Thank you.